Boys and girls, welcome back to the ITV Math show. Before we went for the ad break, we did a problem here where we had to sketch the cubic graph in calculus. This was for grade 12s only. We said f of x is equal to, that was the question. For 12 marks, you had to sketch the graph. So this was all the calculation. Let x equal to 0, solve for y, factor and remainder theorem to get your first factor, synthetic division to get your quotient, take your quotient, factorize it, you got your two x values, your x intercepts. We then went on to SPs, and that's where we used derivative. You always use derivative for your stationary points. Whenever we're talking about your turning points or your stationary points on a cubic function, we're always talking about the derivative. So we use the derivative, we make it equal to 0, factorize the derivative, we get our two x values, take each of these x values, plug it back into original, not back into here, otherwise you'll get 0. Put it back into here, we get our corresponding y values. Let's now sketch the graph. Now I told you guys during the ad break, sketch the graph and let's see how well you do. So let's put the graph down, let's see what the graph is going to look like. So we've got that, y is equal to 3, y intercept. So we go 1, 2, 3, y is equal to 3. X is equal to 1, x is equal to 1, or x is equal to negative 3. There we go, negative 3. So negative 1, negative 2, negative 3. There we go. Those are our two x intercepts. Turning point. Minus 5 over 3. Now minus 5 over 3 is minus 1,6666, which is minus 1,67. Now that's minus 1, that's minus 2, that's minus 1,5, minus 1,66 should be there. So that's about that's negative 5 over 3 and 9,48. So that should be the point. So let's put it down, minus 5 over 3, 9,48. That is your first turning point, and we put a dotted line. We put a dotted line through your x value, and now we've got 1 and 0. Now 1 and 0, not only was it your x intercept, it is now also the turning point of the graph. So now we put another dotted line going through 1 and 0. Let's just put it here. That's the point 1 and 0. And now we join the dots. Now it's a positive graph, so it goes from the bottom up. So let's draw the shape of the graph. Let's do it in a different color so that you can see it. We start at the bottom. It goes increasing, 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 increasing until stationary point, and which is a turning point. Changes direction, decreasing, 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 cuts through there, supposed to cut through here, but it's also a turning point. Normally the graph would have went down and went up, but it's also the turning point. So it turns here and continues up. So it's increasing from negative infinity up to minus 5,3, and this is an exam question. For which values of x is the graph increasing? It's increasing from negative infinity. So let's write it in a different color. All right. So it's increasing. It's increasing from negative infinity up to negative 5 over 3. That's the first point where it's increasing. It's also increasing because it's increasing here. Remember, this is the journey. This is the path of the graph. It's increasing, increasing up till there. Now it's decreasing from negative 5 over 3 to 1, and it's increasing again from 1 to positive infinity. So from 1 to positive infinity, it's increasing. Where is it decreasing? Where is this graph decreasing? The graph is obviously decreasing between these two x values, because the question will say for which values of x is the graph increasing or decreasing. So all we do now is it's decreasing from minus 5 over 3 up to 1. Both of them excluded. We cannot put included because those are your stationary points. The values of minus 5 over 3 and 1 are excluded. Okay, so that is how you would interpret the increasing and decreasing component of this function. Okay? So that was how to sketch the graph. Let's now do the reverse. What if the graph was given and you needed to find the equation? Okay, don't worry about point of inflection. We will get to point of inflection when we are done with this. I will do some graph interpretation and show you exactly what all these graphs mean. Now, this is a very important calculus, like I told you from the start, so important. It's worth 40 marks in the exam. You can score full marks for calculus, but you just need to know what you are doing. So